Hi guys, today we're going to learn about the pigeonhole principle. In the previous lesson to this, we learned about counting techniques. The pigeonhole principle is another useful counting technique. For the pigeonhole principle, if n plus 1 or more pigeons are placed into n pigeonholes, then at least one pigeonhole must contain 2 or more pigeons. So let's have a look at what this may look like. So if we have, say, 4 pigeonholes, these are the boxes here, and that means that we must have n plus 1 pigeons. So we must have 5 pigeons. These X's are going to stand for pigeons. So if we move our first pigeon, or X, and put it into the first pigeonhole or box, we have one pigeon in one pigeonhole. If we move our second one, we can put it into the second box. If we move our third one, we can put it in the third box. And if we move our fourth one, we can put it in the fourth box. But we still have one pigeon over here that we need to put into one of the holes. So when we pick up this pigeon and put it into one of the holes, the pigeonholes, then at least one pigeonhole must contain 2 or more pigeons. This is because, remember, we started off with n pigeonholes equaling 4. So that was our pigeonholes. N. So for our pigeons, we have n plus 1. So it will equal 4 plus 1, which equals 5 pigeons. So, if 5 or more pigeons are placed into 4 pigeonholes, then at least one pigeonhole must contain 2 or more pigeons. Let's have a look at this by placing our pigeons into different holes. So we're going to start off with our 5 pigeons again. Okay, I'm going to pick up the first pigeon and I'm going to place it in the first pigeonhole. I'm going to pick up the second pigeon and I'm going to place it also in the first pigeonhole. I'm going to pick up the third pigeon and place it in the second pigeonhole. Pick up the fourth pigeon, place it also in the second pigeonhole, and pick up my 5th pigeon, and I'm going to put that in my 3rd pigeonhole. Now, if we look at this, we have 5 or more pigeons are placed into 4 pigeonholes, then at least one pigeonhole must contain 2 or more pigeons. Now, it's totally okay that our 4th pigeonhole is empty because we still have at least one pigeonhole containing 2 or more pigeons, and that is true for both our first and our second pigeonhole. So our proof for this is to suppose that there are n pigeonholes and only one pigeon in each hole. Then the maximum number of pigeons is n. But there are n plus 1 pigeons, so the assumption that there is only one pigeon per hole is wrong. Therefore, at least one pigeonhole must contain 2 or more pigeons. Let's have a look at an example. A paragraph contains 33 words. Show that there must be at least 2 words that start with the same letter. So, first what we need to think about is how many letters are in the alphabet. And there are 26 letters in the alphabet, right? So let's write that down. So if there are 26 letters in the alphabet, that means that there only needs to be 27 words, so at least 2 words will start with the same letter. So at least 27 words, so that at least, more can happen, at least 2 words will start with the same letter. Because if all of the first 26 words start with the letters in order from A to Z, then the 27th word has to start with one of those 26 letters. In that way, we'll have our double up. So since the paragraph contains 33 words, so since the paragraph contains 33 words, then, well, which is more than 26, so 33 is more than 26, at least 2 words must start with the same letter. So, recapping, a paragraph contains 33 words, show that there must be at least 2 words that start with the same letter. Here we have shown that at least 2 words will start with the same letter because we know that there are 26 letters in the alphabet, so at least 27 words that start with at least 2 words, so that at least 2 words will start with the same letter. So since the paragraph contains 33 words and 33 is greater than 26, at least 2 words must start with the same letter. That's how we show our proof, or how we show that that happens for our example. For the generalized pigeonhole principle, if n pigeons are placed into k pigeonholes where n is greater than k, then at least one pigeonhole must contain at least n on k pigeons. The proof for the generalized pigeonhole principle is, suppose there is only one pigeon in each of the pigeonholes. Then the maximum number of pigeons is k, but n is greater than k, so the assumption of one pigeon per hole is wrong. Therefore, there must be more than one pigeon in at least one hole. The average number of pigeons per pigeonhole must be the number of pigeons divided by the number of pigeonholes, which equals n on k, where n stands for pigeons and k stands for pigeonholes. Each pigeonhole will be below, on, or above average, so at least one pigeonhole must contain n on k pigeons. Let's look at an example. A group of 75 people in a singing contest are placed into 4 different audition rooms according to their category: males, females, children, and groups. If there are at least X people in one of the rooms, find the value of X. So, what we need to do first is we need to state how many people there are, and our people are our pigeons. So, there are 75 people, and then we need to state how many rooms there are, and these rooms are our pigeonholes, so and 4 rooms. So what we know is that our n equals pigeons, so we write n equals 75, and our k equals our pigeonholes, so our k equals 4. What we then know is that we have n over k, which equals to our 75, which is our n, over our 4, which is our k, where 75 over 4 is 18 3/4. So x must be greater than or equal to 18 3/4, and because we can't have a 3/4 of a person, we round up to get x as a whole number. So if n on k is not a whole number, we always round up. So we get 18 3/4 to equal 19. So therefore, there are at least 19 people, in our case, or pigeons, but in our case, people, in at least, pen's not working here, in at least one of the rooms, where our rooms are our pigeonholes. So that is the pigeonhole principle, but we just need to note over here, if n on k is not a whole number, we always round up. So if you are following through the Maths in Focus by Margaret Groves Mathematics Essential 1 textbook, you would now complete exercise 302.